And hello and welcome to Solving Systems of Linear Equations by the Substitution and Addition method. This will be split into two parts, two sections, one for the substitution method and one for the addition method. So let's get started. With the substitution method, you're going to need to know this procedure. Please refer to your notes in the PDF or pause the video now to read over these. Now to actually get our hands dirty and look at some examples, we have this problem set that says solve the following systems of linear equations with the substitution method. Now with the substitution method, what you're going to want to do is find an equation that's going to be easy to solve for. In this case, if we look with this first equation, x or y would be easy to solve for since there is no coefficient in front of the other. If we look in equation 2, x would be more hard to solve for since there is a coefficient in front of it, and the y would not be too bad since there's just a -1 coefficient. So I'm going to go ahead and solve this first equation, x plus y equals 4. I'm going to solve it for y. So when we do that, we're going to subtract x on both sides. So we have y equals a -x plus 4. The procedure now is to take what you just solved for from the first equation and plug it into the variable that it's equaling in the second equation, the one that you did not solve for. So let's take 2x minus y equals -1. Now where we see a y, let's replace it with everything we just solved for. So we'll make sure that negative's out in front, that negative sign right there, because it's in the original problem. So y equals a -x plus 4 equals -1. And what I like to do now is to distribute that -1 across to everything inside the parentheses. So we have 2x, a minus times a minus is a positive x, and a minus times a positive is a -4 equals -1. Now let's go to the variables on one side and the numbers, regular numbers, on the other. So to do that, let's add together x and 2x will give us 3x minus 4 equals -1. To get 3x by itself, let's add 4 on both sides. So we have 3x equals, if we look, -1 plus 4 is 3. Finally get x by itself, divide by 3 on both sides, and you have x equals 3 divided by 3, or just 1. So now that we have a solution to one of the variables, let's take what we just found and plug it into what we solved for originally. So we have x equals 1. Excuse me. Get back. So let's take, we have y equals the -x plus 4. That's what we solved for originally, and this time, since we know that x is equal to 1, just plug a 1 in for x and solve. So we have -1 plus 4 is 3. So the solution to this linear equation, or systems of linear equations, would be the coordinate pair 1 for x and 3 for y. Okay, so let's take a look at another example. So we're still using the substitution method and looking for an equation that would be easy to work with. I really like using the first equation here because there are no coefficients in front of it. So let's solve for y again. So x plus y equals 3. Let's get rid of the x by subtracting on both sides to get y by itself. So we have y equals negative x plus 3. As you might have guessed, we're going to take the second equation and we're going to take what we just found and plug it in for that variable. So 2x plus 2y equals negative 4. Now, where we see the y, let's plug in the negative x plus 3. So that gives us 2x plus 2 times the quantity negative x plus 3, all that equals negative 4. Now let's go through and distribute the 2 to everything inside the parentheses. So we have 2x plus 2 times a negative x plus 2 times 3 equals negative 4. Let's go through and solve, or simplify. Plus 2 times negative x is a negative 2x plus, and we have 2 times 3 is 6 equals 4. And if you look here, that's going to go to 0, leaving you with 6 equals 4. And as we've seen with the graphing section before, that is a false statement. 6 is never equal to 4, so this is no solution. That is the answer to this system of linear equations. Okay, and finally, to conclude this portion of the substitution method, let's look at this final example. So if you notice, this is already solved for a variable, so we don't have to do anything with it. So let's just take the second equation, 2y equals 6 minus 4x, and everywhere we see a y, let's just plug in this first equation. Let's just plug in this information right here. So 2 times negative 2x plus 3 equals 6 minus 4y. Taking this 2 and distributing it to everything inside the parentheses, we have 2 times negative 2x plus 2 times 3 equals 6 minus 4x. And if we simplify, we have negative 4x plus 6 equals 6 minus 4x. And if we just simply rearrange the left side of the equation, 6 minus 4x equals 6 minus 4x, I believe you'll be able to see that that is a true statement because both sides equal each other, meaning that this has infinitely many solutions. That is the answer to this system of linear equations.